Let's discuss a question from vibration. We have been given a small block which is free to slide. It is free to slide on a smooth concave surface of radius r, and obviously because of the gravity it will be resting at the centermost or the bottommost position uh, in equilibrium. Now if I perturb it, let's say, this is the thing, okay, and this is, so here is the equilibrium position, this is my equilibrium position. Now this is my center, and if I perturb it, let's say by angle theta, this is my theta, okay, and if I perturb it such that it is here. Now at this point of time, if I perturb it and leave it, you have mg acting like this. The normal reaction is acting normal to the surface going towards the center, because this normal to a circle always passes through the center. So you have mg here. Now if I resolve, there are two directions here. If you recollect here, this is mg, okay, this is my tangential and this is my normal direction. So along this vertical direction, the component is mg cos theta, which gets balanced by normal reaction n. Along this direction, the component is mg sin theta, which basically produces an unbalanced force, and that basically is the restoring force, and that tries to bring back the block to its equilibrium position. Now at equilibrium position, during this process it gains some kinetic energy, and at this equilibrium position it has some kinetic energy, so it doesn't stop, it goes again further upwards, and it goes till a point where the kinetic energy is converted into potential energy, and again you have an unbalanced force here. So this process just goes on when you perturb it and leave it. So how do we solve this? How do we solve this method? Okay, so what we do is, in this direction we write down the summation of forces after perturbation. So this is summation of forces in the tangential direction. Okay, so in this direction the only force that is acting in this direction is mg. Now this is theta, so mg cos theta is acting normal to the incline, mg sin theta is acting downward, so mg sin theta. Okay, now this theta is in this way, and that's why I'll assume, okay, so this I take, why I'll tell you this, I'll take the upward direction as positive, because I have perturbed in the same direction. If you remember the spring mass damper derivation, I always take the direction of x. I perturb it from the equilibrium position, and this is the direction where I take x dot and x double dot. So in the same way I have perturbed it by angle theta such that it's like this. So I'll just take my acceleration also in this direction. Okay, so mg minus mg sin theta, because mg sin theta is acting downwards and I have considered upward direction positive, so minus mg sin theta is the force into m at. Okay, that is my acceleration. Okay, now if this distance along the curve, let me call it as x. Okay, so it is perturbed by distance x. Okay, so acceleration I can write x double dot, okay, and this is minus mg sin theta. Now for small theta, assume that perturbation is very small, so sin theta is theta. If you remember that sin theta by theta is 1 when the limit theta tends to 0. So when theta is very small, sin theta by theta is 1. So based on that we get we get that sin theta is theta. And also remember that when theta is very small, the curvature distance x and this x is almost same, and x is basically r sin theta, and it's nothing but x is equal to r theta, because theta is small. So if I substitute everything here, so minus mg sin theta is theta is mx double dot, okay, and I can convert everything now. I can just double differentiate this. It's r theta dot and x double dot is r theta double dot, or I can convert in theta in x, so whatever way. So mg theta is m r theta double dot. So this is g by r theta is equal to theta dot. So anything which, any degree of freedom which is in this form, theta double dot minus something into theta. Now this something is your natural frequency, okay, of vibration. So omega n is g by r, going by this, omega n is root g by r, and the time period is given by 2 pi by omega n, which is 2 pi root r by g. So let's look at the options. 2 pi r by g, D is the answer. This is a very good problem. So we have just used our forced balance method, perturb it by theta and then just balance the force along the curve, and that will give you, and bring it in our standard form, which is in this form. So any degree of freedom, you can, instead of bringing in theta, we can bring in x double dot, and this will be x, the same thing. Instead of converting x double dot into theta double, just convert theta into x, so it will be x by r, and directly you will get x double dot is equal to minus g by r x. So you have to just bring in this equivalent form. That is the objective in the force method. Bring in this form so that you get the natural frequency, and that's why after that you can get anything. And here what is asked is time period, which is 2 pi by omega. So 2 pi root r by g is the time period. Thank you.